Assalamualaikum and greetings everyone. My name is Muhammad Shazwan bin Muhammad Rusli and my registration number is 159647. I will represent myself as member A.
Assalamualaikum and hello everyone. My name is Norliana Nabila binti Talha and my registration number is 1559C9. I introduce myself as a member B.
Hi, my name is Nur Aina binti Roslan and my matrix number is 159648 and I am a group member for C.
Hi, I am group member D. My name is Nazwa Talha binti Muhammad Hatta, registration number 155999.
Assalamualaikum everyone. I'm Afizan bin Ahmad Fuad. My matrix number 160045. We are from group B12, course EAA, Structures and Strengths of Material Laboratory. We would like to present to all of you about S1 Torsion.
For the introduction, we will determine what is torque. So, torque is a moment that twists a material. Its value depends on three characteristics, which is the magnitude of force, the location of applied force, and the type of the material. It is necessary for us to know the torque value under any torsional force by performing torsion tests. By the test, several outputs such as the shear stress, shear modulus, and maximum torque can be acquired. Different materials show different torsion. For example, rubber material will try to revert to its original shape. Hence, our objective is to determine the torque, shear stress, and shear strain from a PVC hose material at 5 different load conditions.
For A section, I use 0.4513 Newton battery as load, PVC hose as the tested material, disc for radius measurement, thread for transferring load, a protractor, a ruler, a pencil, a marker pen, a steel clamp, a scissor, and sellotape.
This is apparatus that I use for this experiment, which is vise, protractor, ruler, marker, thread, battery, disc, scissor, and PVC hole pipe.
So here is my apparatus for this experiment where I use thread, protector, load 1.3342 Newton or 136 gram, marker pen, ruler, sellotape, disc, clamp, and PVC hose with length 30 cm.
So here is my apparatus for this experiment. I have a disc, a protector, a ruler, a marker pen, a steel clamp, a thread, 4 size C battery which is weighted 182 gram, and lastly 300 mm length and 21 diameter of PVC hose.
This is apparatus that we use for this experiment S1 torsion, which is vise, 1 protector, 2 steel ruler, 3 marker pen, 4 thread, 5 battery, 6 disc, 7 cutter, 8 G-clamp or clipper, and 9 PVC hose pipe.
For setting up section A, first, the center hole of the disc is widened out by scraping it using scissor. Then, the PVC hose is placed through the center hole of the disc. The steel clamp is used to prevent the PVC hose from moving. The 0.4513 Newton load is tied by thread and placed along the disc circumference by sellotape. Section A setup is done.
This is how I will set up this experiment. This is from front view. This is from side view.
Here is the overview for the experiment.
Here is my experimental setup. Steel clipper is used to fix the PVC hose pipe in place. and the disc is placed at 300 mm from the origin. Then 182 grams of battery size C is placed along the circumference of the disc until the load rests in perpendicular position.
This is setup section E. First, the center of hole of the disc is widened out by scraping it using cutter. Then, the PVC hose is placed to the center of hole of the disc. Thick length is used to prevent the PVC hose from moving. The 2.2565 Newton load is tied by sellotape and placed along the disc circumference first by sellotape. Section E setup is done.
For Section A methodology, firstly, the initial point which before load is applied is marked. After that, the load is released and the second point is marked. At this point, the material is twisted by the released load. From the marked point, the rotation angle can be gained. It then will be recorded and used to find radian and torque afterwards.
Load 91 gram is tied with thread and attached to the circumference of the disc using masking tape. And then the end of the pipe is fit using a vise. Now the place of origin is marked. I will release the load down and see the resulting twist on the pipe. After that, I will mark the new place. Finally, after getting both lines, we can determine the torsion.
For methodology section C, firstly, the initial point where load is not applied yet is marked like this. After that, the load 1.3342 Newton is released and then mark the point where the rotation is stopped, like this. So from here we can see the movement of the rotation happen. From the point that I have marked, the rotation angle can be determined, which is 50 degree, and the angle is recorded to find the radian and torque afterwards.
182 grams of battery size C is placed along the circumference of the disc until the load rests in perpendicular position. The new angle rotation is marked using marker pen. Here we can see the twist occurred on the PVC hose, whereby the initial line and the twist is marked using marker pen along the material, so that we can determine the torsion. Lastly, using mark line on the disc, the initial line and rotation line is extended so we can determine the angle of rotation using a protractor. And here I got 58 degree of angle rotation.
For section E, methodology. Firstly, the initial point which before load is applied is marked. Secondly, the load is released and the second point is marked. For this point, the material is twisted by the released load. From the mark point, the rotation angle can be gained. It then will be recorded and used to find radian and torque afterward.
Here are the graphs that we have plotted. From torque versus twist graph, increase of twist leads to torque increment. The maximum torque for material hasn't yet achieved even at 1.117 radian. The slope shows that modulus of rigidity is 0.0014 Newton per square millimeter. From shear stress versus shear strain graph, increase of shear stress leads to the increasing of shear strain. The material hasn't yet achieved the yield point at the moment. The slope shows that the modulus of rigidity G is 0.001 Newton per square millimeter. For our discussion, as the load is increased, the degree rotation of the twisted material also increased until at some point. Rubber material will revert to its original shape after load is removed. From the graphs, the modulus of rigidity G value can be gained and checked. The modulus of rigidity G can be known from the slope and from the formula given. From the shear stress versus shear strain graph, the slope is 0.001 Newton per square millimeter, and compared to the standard shear modulus of rubber of 0.993637 Newton per square millimeter, our selected material is considered much lower of its shear modulus. The condition is same for torque versus angle of twist graph, which is 0.0014 Newton per square millimeter. Less shear modulus indicates that our material is too soft and flexible. There is only horizontal displacement occurring throughout the test without any vertical displacement.
For the conclusion, our objective which are to do the torsion test and to obtain the modulus of rigidity of the PVC hose pipe are achieved. According to the common materials of modulus of rigidity, cast steel is approximately 78,000 Newton over millimeter square, then for the concrete is approximately 21,000 Newton millimeter square. Also for the aluminium is approximately 28,000 Newton over millimeter square. And lastly, for rubber, which is 0.3 Newton over millimeter square. So we can determine that our PVC rubber hose used in this experiment whereby obtain the value of modulus of rigidity is 0.001 Newton over millimeter square, which is too flexible and soft because lower value of shear modulus indicates the high flexibility of materials. Next, we can also deduce that the load is exerted in perpendicular position to the torque shown. In addition, it is proven that the shear stress correlates with shear strain. Some recommended precautions are the angle of twist should be measured carefully. In addition, the material should be clamped to rigid position for best result. There are several errors need to be avoided, such as absolute error, resolution error, parallax error, misalignment error, and systematic error. It is important to know the torsion of a material in construction, such as reinforced concrete and manufacturing industry. Lastly, we can refer to any standards such as ASTM A938-metal wire torsion testing to compare with our result. That's all. Thank you.